Gibbs Academy. In this lesson, we are going to discuss rules that are used to reduce the complex diagram of a control system. So, reducing a block diagram, those big complex diagrams require some rules, and most of the time these block diagrams are complicated. The purpose of reducing them is for it to ease the simplification to get the transfer functions of the overall gate of the control system. So we want to see some of the rules, and rule number one, we are considering when the blocks are in series. So the rule number one is combining blocks in series for example, you can have a block diagram like this. You can have this one to be G1, G2. So the equivalence of those block diagrams are arranged in series. And what is the equivalent of this? The equivalent of this would be the product of G1, G2. We shall have G1, G2. That is rule number one. So the blocks which are in series, the equivalent of this is going to be G1, G2. Rule number two is combining blocks in parallel. So number two is combining blocks in parallel. E.g., we can have this G1, G2. So these two block diagrams, as the guiding principle, the arrows, they are all pointing to the summing points. So this arrow and this arrow is heading to the summing point. So these two, we say they are in parallel. So these blocks are in parallel. So what is the equivalent of that? The equivalent of that, based on the summing, you see this plus, then you are going to say G1 plus G2. So the equivalent of this will be G1 plus G2. That is so this is the equivalent of this. If it was negative, if here was negative, then we could have said G1 minus G2. If here was negative, then we shall take this. Now, but for our case like this, plus, then we are going to say G1 plus G2. So that is the rule. So rule number two. Rule number three rule number three is when you are talking about the deck of points, moving a deck of point after a block. So rule number 3 is moving a big of point after a block. Yes. So moving a big of point after a block. For example, we can have this. This one is G. This is the input. So if you want to move this big of point after the block, so this rule, how do we move this big of point after the block? Or we move this after the deck of point. So what we do, what is the equivalent? We want to move this ahead of the block. The equivalent of that is going to be equivalent to it is going to be equivalent to that point. Then we are moving back, then it is going to be the reciprocal. This is I. So the equivalent of this is that. Now rule number 4 is moving a takeoff point after or ahead of the block. So moving takeoff point ahead of block. Moving a takeoff point ahead of block. So here we want to move a takeoff point ahead of the block. We want to move the block ahead. We want to move a takeoff point ahead of the block. So example, we can have a block like this. So we want to move this ahead of that. The equivalent of this is going to be equals to G, and then so the equivalent of this is this, moving a takeoff point ahead of block, ahead of the block. So all these rules are represented with blocks. So the rules are represented with blocks. Now rule number 5 is now when we are talking about the takeoff point. So in these rules we were talking about the points, So what happens when you move this after the block? The equivalence of that is that moving a takeoff point ahead of the block. So you are moving this ahead of that. Then the equivalence of this is that. So let's see the summing points, and that will lead us to rule number 5. So rule number 5 is moving summing point ahead of a block. Moving summing point ahead of the block. You can have this one. The input. So what is the equivalence of this? So the equivalence of this is going to be to look like this. That is the equivalence. So the equivalence of that is going to behave that way. And this is the summing point. Summing point. So the equivalence of this is equals to that. It's equivalence to that block diagram. And let's see the opposite of that. And that will lead us to number 6. Number 6 is when we have something like, when we have a block diagram. What will be the equivalence of that? The equivalence of this is going to be look like this. That will be the equivalence. So that is the rule. When we have this, we are moving this ahead of the block, ahead of the summing. The equivalence of this is going to be that. The equivalence of this moving a summing point ahead of a block. You have this, you want to move this ahead of this block. The equivalence of that is that one. Now the last rule is way over eliminating the loops. So let's see that one. So the rule number 7 is eliminating a loop. Eliminating loop, which in most cases we call it the feedback. Feedback loop. How do we eliminate? For example, when we have a closed loop system like this, G1, and that one C. So how do we eliminate the loop? So we use the formula that we had derived from previous lessons, and the transfer function of this system, transfer function or you call it overall gain, overall gains of the system is given by, that is a ZRC S over R is always given by G all over 1 plus or G dot H dot. So basing on that formula, then we shall be able to reduce that feedback loop. So using that, then we are going to say this multiplied by using the formula. Then we shall have a block diagram like this. See, this is the input. Now, if it is a closed loop, it's a closed loop system having that feedback, then what we want to do is to use this formula. So reductions of this, the equivalence of that is going to be GS all over 1 plus GS S, and that will be the equivalent of that system. So as we had earlier talked about the rules of the control system, we say they are 7, and all of them are represented with blocks. So rules are represented by blocks. So you note that. So let's see an example. You can be given a system like this. So we can be told a question: simplify the block diagrams shown and obtain a closed loop transfer functions. So the question could be: obtain the overall transfer functions of the system, which in our case the block diagram. So this one is G1 and this one is G2. So based on our rules, rule number 2, you see this is a summing point, this is plus plus, then this one is heading to the summing point, this one is also heading to the summing point. So this one we can reduce by adding G1, G2. So we shall have reducing this, we shall have G1 plus G2. And then again, these two arrows are heading to the summing. So what we are going to do is that we are going to say this is negative, this is negative, so we are going to say G3 minus G4, and then it goes to that summing point. So it goes here. So this, it is heading to the summing point, heading to the summing point, and then we are forced to use the rule number 2, which says that when they are arranged in parallel, then the rule is you are saying based on what you have been given, this is negative, then we are going to say G3, G4. So G3 plus G4. And then from there, then we are supposed to further reduce. So we are supposed to further reduce. So this one forms the forward part of the transfer function. So this one forms forward part of the transfer function. And then this one forms the feedback. This one forms the feedback loop. A feedback loop. So since there is the feedback loop, then it means we are going to be forced to use the rule number 7. And rule number 7, we were using the formula which we were saying CS all over RS is equals to GS all over 1 minus GS H that. Remember in our previous lesson we had derived this equation, so we are now applying it. So from there, then we apply that same formula here. So we are applying. So we want now to reduce this formula based on rule number 7. So this is what we have. So based on that, then we are going to get, reducing this, then it means we are going to get a single block. So based on that formula, G corresponds to G1 plus G2. So it's going to be G1 plus G2 all over 1. Because there is a negative here, then it's going to be positive. So 1 plus G. G corresponds to this one, which we can introduce the bracket G1 plus G2 with close, and then multiply by H, which correspond to the feedback loop. So it's going to be G1, G2. We had made this one should be negative. So it's going to be G1, that is a G3 minus G4. And we have reduced that block diagram. And then next time.